Calculating work using vectors. Alright, so we're going to look through this problem. It's really an application of vectors, right? Now, let us see what this thing could be. It says, you pull a wagon horizontally by exerting a force of 200 newtons on the angle. So remember, you pull it horizontally, so you're going across, right? Now, you pull, you're going across, you pull 200 newtons on the angle this way. If the angle makes an angle, if the angle makes an angle, interesting. If the angle makes an angle of 60 degrees with the horizontal, 60 degrees with the horizontal, find the work done in moving the trolley 100 meters. All right. We'll see what's going to happen here. So you have the angle of the trolley, you have the horizontal. This don't look like 60 degrees. This is supposed to be 60 degrees. Kind of move it this way, make it look more like 60 degrees. All right. And this is a 200 newtons, this way. 60 degrees. I just write 60 and leave out the degrees for now. Alright. You want the work done in moving this way 100 meters. Now you know from your physics class that work is equal to force times distance. FD, alright? F times D, force times distance. Now, the force is a vector. And this distance, it tells you the direction. Right? The magnitude is 100 meters. The direction is this way. So it's a vector. So you're going to really have to multiply a vector by another vector. How do you do that? Alright, what you're going to have to do is resolve each vector into their horizontal and vertical components. So one vector horizontal will multiply the other vectors horizontal plus one vector's vertical will multiply the other vector's vertical. That is going to that is what you have to do. You're going to have to do, right? So, let us see. We're going to have to resolve this 200 newtons at 60 in its horizontal and vertical component. So, we have our 200 newtons. And let me draw it thick. And then we have our horizontal thinner and our vertical. Alright, good. Let me draw the vertical a bit straighter, a bit more straight. Now, even though it doesn't really look like 60, but this is our 60 degrees. So let us call this V and this H. H1 and V1. Or since it's the force, HF and VF. Just making up those names for it. Although you know that the books and so on sometimes use I for the horizontal and J for the vertical. Now, the horizontal force equal, what would it be? You have to remember that cos 60 is adjacent, which is horizontal force, over hypotenuse. Hypotenuse is 200. So transposing, horizontal force is 200 cos 60. And the vertical force is 200 what? You have to remember, using trigonometry, this sine 60 is opposite, which is vertical force, over the adjacent, over the hypotenuse, 200. So transposing is 200 sine 60. Right? So you can calculate each. So, calculator. Alright. So, we have 200 cos 60 equal 100. And then the other calculation is 200 sine 60, 173.2. So it's 173.2. You see that? So this is the horizontal is 100 and this one is 173.2. Does look like it, but it was not drawn to scale. Alright, but let me redraw it properly. Redraw it properly, kind of properly. That probably would look more like it. Alright, we have our 60 degrees here. This is 173.2, this is 100 newtons, right? Alright, so this going this way and this way. Since they are vectors, we draw the arrows on them. Now, the thing is, the distance vector now. So, remember, this is for the force. What about the distance? Let's put the distance out here. Right? Well, the thing is, this, and by the way, something like this, you may see it being written as the force is equal to 100I plus 173.2 J. Because remember, the I is horizontal and the J vertical. Probably could be written like that too. What about the distance? Well, the distance is, you're going 100 meters this way, horizontally, but how much vertically? You're not lifting it up nor pushing it down, so it's 0. Right? So the distance vector is going to be 100I horizontally plus 0J vertically. Alright? See that? No, you're not going to add them, You're not adding them, you're multiplying them. So what you're finding is what they call the dot product. You remember the dot product in previous video? So the work is equal to force times distance is equal to, it's going to be 100I plus 173.2J times 100I plus 0J. But being that is the dot product, what you're going to have is I by I, 100 times 100I times 100I plus 173.2J times 0J. This gives you 100 is 100. The I would disappear. Because you remember from complex numbers, I would be the square root of -1 and the square root of -1 square. Right? So it's 100I by 100I. So it's in newtons. 0 times anything give a 0. So here is going to be, and what you have is 100 Newton, 100, which is 10,000 newtons. No, not Newton, Newton meter. Is Newton force multiplied by meters. But the name for the Newton meter is what? The Joule. Thing is named after somebody named Charles Joule. Scientist Charles Joule. So a Newton meter. So it's 10,000 joules of work.